Cookbook for the Universe. Black holes, engines of resonance at the galactic scale. Black holes are the mysterious engines of the cosmos. Acting as transformers, they absorb energy and matter, redistributing it across the galactic plane. These emissions, shaped by the harmonic mean, create waves that ripple across galaxies. Black holes are no longer enigmatic voids swallowing matter indiscriminately. They are engines of resonance. Pivotal nodes in the universe's vast and interconnected symphony. Within the framework of relative gravity, black holes are seen not merely as gravitational sinks, but as dynamic systems that transform, regulate, and redistribute energy across cosmic scales. At their cores, black holes exhibit profound relationships between mass, energy, and time, embodying the principles of the harmonic mean. Acting as spatial induction engines, black holes balance opposing forces, the inward pull of gravity and the outward radiation of energy. This interplay transforms them into resonant oscillators, where alternating currents of matter and energy perpetuate a cyclical rhythm of cosmic balance. 12.1 The mechanics of a black hole. The mechanics of a black hole can be theorized to be like a spatial induction engine. For example, consider a vibrating flat disk similar to an audio speaker and microphone. The black hole, if to consist of alternating currents, could vibrate in a similar way. This analogy proposes oscillatory behavior of alternating currents, suggesting that black holes interact dynamically with the surrounding space-time. The spatial induction engine concept, when applied to a black hole in the framework. By Orion Carl Daly 1. Aka, Essay on Relative Gravity to describe the mechanics of the universe of relative gravity. Presents a fascinating way of understanding how black holes might function and interact with surrounding space-time. A spatial induction engine is a conceptual framework that draws parallels between the physical dynamics of celestial phenomena such as black holes and the principles of electromagnetic induction, particularly as outlined by Faraday's law. It seeks to describe how spacetime itself, under extreme gravitational conditions, can act as a medium for energy transformation, matter creation, and the exchange of forces. 12.1.1 Key characteristics of a spatial induction engine. Energy compression and transformation. In celestial contexts, such as within a black hole, the immense gravitational forces compress energy and matter into a singularity or near-singularity state. This compression mirrors how electrical energy is concentrated in an inductor or capacitor in electromagnetic systems. Wave-particle interactions. Spatial induction engines can be thought of as engines where spacetime curvature interacts with matter and energy at quantum and cosmic scales. The dynamics create resonant frequencies, akin to the oscillations in an electric circuit, which could manifest as gravitational waves or electromagnetic emissions, for example quasars. Analogous to alternating current systems. Just as an electromagnetic alternator converts mechanical energy into electrical energy through oscillating magnetic fields, a spatial induction engine operates through oscillating spacetime curvatures. These oscillations allow energy and matter to be redistributed within the universe, contributing to phenomena such as jets from black holes where galactic energy flows. Harmonic resonance and energy redistribution. The harmonic mean plays a central role in ensuring that the interactions within the spatial induction engine remain balanced and synchronized. This resonance governs the stability and coherence of energy propagation, aligning with the universal constants like the speed of light. Manifold and vector dynamics. By Orion Carl Daly 2. Cookbook for the Universe. The spatial induction engine can be represented as a manifold with multiple interacting dimensions, e.g., x, y, z coordinates and temporal dynamics. Vectors such as ZR, derived from thermal or gravitational dynamics, for example the Carnot cycle, act as catalysts for energy redistribution, sustaining the engine's operation. Singularities as engine cores. In a black hole, the singularity functions as the core of the engine, where extreme gravitational compression leads to the creation of new energy states or even new universes. This core acts as both a collector drawing in energy and matter and a radiator emitting energy through phenomena like Hawking radiation or relativistic jets. 12.1.2 Applications and implications. Black holes as spatial induction engines. Black holes absorb matter and energy, converting them into high-energy emissions such as quasars. This aligns with the concept of a spatial induction engine, where spacetime acts as the medium for energy transformation. Galactic evolution. Spatial induction engines can explain how galaxies maintain coherence and evolve over time. The energy redistribution processes align with the harmonic mean and Fibonacci-like scaling, ensuring dynamic stability. Time and energy dynamics. Spatial induction engines highlight the relationship between time and energy, where spatial time acts as the frame for the oscillations and transformations, contributing to the evolution of dimensions and forces. Universal connectivity. Through gravitational and electromagnetic interactions, spatial induction engines link cosmic structures, for example black holes, stars, galaxies, into a self-regulating network, reinforcing the interconnectedness of the universe. 12.1.3 In summary. A spatial induction engine is a theoretical model that combines gravitational and electromagnetic principles to describe how spacetime acts as an engine for energy transformation, redistribution, and creation. It unifies cosmic scale phenomena with harmonic and cyclical principles, offering a profound lens to understand the mechanics and evolution of the universe. 12.2 Conceptual states of transference in the spatial induction engine. By Ryan Carl Daly 3. Aka, essay on relative gravity to describe the mechanics of the universe in terms of a waveguide. When amplitude is a property of the collector cavity and velocity a measure of the period of containment, frequency is considered expressed. Absorption. Black holes act as collector cavities, absorbing matter and energy while overcoming the inertia of incoming forces through superposition. In the spatial induction engine, all forces are considered absorbed within a collector cavity or vortex, for example, similar thought like a black hole. A counterforce in superposition which overcomes the inertia of forces it collects. Containment. Absorbed forces are stabilized and normalized within a spatial manifold, akin to the Einstein-Rosen bridge, over a period t plus infinity tpm inf t plus infinity. Relative force is collected and contained as a manifold of spatial time similar to an Einstein-Rosen bridge, and for a period of time t with range of plus infinity in duration. Emission. Resonant waves CR are emitted as the output of these interactions, representing potential field strengths and cosmic ripples. As a product of the sum, and represented as a variance of state, relative force becomes an emission of a resonance CR. CR is represented as a synchronistic event of a potential field strength. This is with respect to the manifold. 12.3 The Carnot cycle and black holes. The Carnot cycle frames black holes as thermodynamic engines operating between two reservoirs. Hot reservoir, the intense heat near the event horizon due to accretion and Hawking radiation. Cold reservoir, the cosmic microwave background CMB with a temperature of approximately 2.7 K. Black holes undergo processes analogous to the stages of the Carnot cycle. ISA, thermal expansion. Energy absorption from accreting matter increases the black hole's mass and entropy. Adiabatic expansion. Energy stabilizes within the black hole's manifold with entropy conserved. ISA, thermal compression. Radiation such as Hawking radiation or high-energy jets emits energy outward. Adiabatic compression. The black hole's mass density increases as it emits energy and loses mass, compressing internally. Exploration of existence. By Ryan Carl Daly 4. Cookbook for the Universe 12.4 The complementarity of the two models. The spatial induction engine and the Carnot cycle together provide a comprehensive understanding of black hole dynamics. The spatial induction engine describes the dynamic processes of absorption, containment, and emission, focusing on resonance and energy redistribution. The Carnot cycle offers a thermodynamic lens, emphasizing efficiency and entropy changes during these processes. Black holes as spatial induction engines are inherently dynamic, with oscillating currents of energy and matter. The Carnot cycle frames this behavior within a thermodynamic ideal, revealing how black holes efficiently manage cosmic energy flows. 12.5 Black hole mechanics as galactic induction engines. The supermassive black hole acts as a spatial induction engine, driving the dynamics of the galaxy through the following mechanisms. Gravitational induction. Sagittarius A induces gravitational current loops in surrounding stars and solar systems, analogous to the currents in an electromagnetic coil. These currents create a spiral torque pattern, drawing bodies into stable rotational paths along the galaxy's disk. Energy transfer through field interaction. The black hole's intense field radiates gravitational energy outward, which interacts with the radiated fields of other bodies. Stability arises where relative gravitational potentials balance, anchoring stars and solar systems to their specific galactic orbits. Field saturation zones event horizon. Near the event horizon, gravitational field saturation occurs, pulling matter into the black hole in a direct collapse. Beyond this region, radiated potentials stabilize bodies into orbiting trajectories. By Ryan Carl Daly 5. Aka, essay on relative gravity to describe the mechanics of the universe 12.6 Faraday's principles of electromagnetic induction and black holes. Using Faraday's law, which deals with how changing magnetic fields induce electric currents. This theory posits that the black hole absorbs all forces including gravitational, electromagnetic, etc. into a collector cavity. This absorption requires a counterforce in superposition, which overcomes inertia, allowing forces to accumulate. Just like alternating current AC has an intake and outtake, the black hole can be thought of as modulating these forces and releasing them at a specific point, perhaps near the event horizon or beyond it. 12.7 The Einstein-Rosen bridge and spatial time. The theory builds on the idea of the Einstein-Rosen bridge, commonly known as a wormhole, to model the black hole's inner workings. The forces collected in the black hole are seen as being contained within a manifold of spatial time, where the flow of energy or matter could be regulated by relative force. The duration of this containment could range from a finite time t to infinity plus infinity, depending on the context of the black hole and its interactions with space-time. 12.8 The mechanics of resonance. The mechanics of black holes can be likened to an electrical system, where the harmonic mean governs energy distribution. Gravitational pull as a collector. The immense gravitational pull of a black hole gathers surrounding matter and energy, creating a vortex of superposition. This gravitational field acts as a collector cavity, channeling forces toward the core while generating intense rotational velocities. Event horizon is the containment field. The event horizon, often misconstrued as a boundary of no return, is better understood as a manifold of spatial time. This manifold oscillates between absorbing and radiating energy, akin to a waveguide in an electrical circuit. Core is a resonance emission zone. At the core of a black hole, energy converges into a state of immense density and potential. Here, forces interact and harmonize, emitting resonant waves observable as quasars or other energetic phenomena. These emissions ripple outward, propagating their resonance across galaxies and beyond. Rotational frequencies. The spin of a black hole driven by angular momentum is synchronized with surrounding systems. This resonance aligns with Carl Gustav Jung's idea of synchronicity, where effects are constant, even if their connections appear disjointed. By Orion Carl Daly 6. Cookbook for the Universe 12.9 Emission of resonance CR in quasars. Once the forces are absorbed and normalized in the black hole, they are released as a resonance CR, which is a potential field strength representing a synchronistic event. This emission might be related to phenomena like quasars, which are thought to be the high-energy emissions from the region surrounding a black hole. The emission of ZR could be understood as a self-regulating process of the black hole, possibly explaining the powerful jets and emissions associated with quasars. The quasar could be seen as a regulated output of the black hole's spatial induction engine, acting as the stabilizing or balancing event that occurs when forces reach a certain threshold. 12.10 Harmonic mean is the black hole's blueprint. Black holes are seen to operate under the principle of the harmonic mean, which ensures balance and connectivity across vast scales. Consider the relationships between a galaxy's black hole and its surrounding stellar systems. Energy redistribution. A black hole acts as a transformer, stepping down high-energy inputs into distributed outputs. These outputs manifest as electromagnetic waves, gravitational distortions, and energetic bursts that sustain galactic dynamics. Stabilizing forces. The harmonic mean mediates the distribution of mass-energy interactions, ensuring stability across the galactic plane. Each star, planet, and particle is influenced by the rhythmic pulse emanating from the black hole, aligning their motion and existence with the greater cosmic order. 12.11 Beyond the visible, a cosmic grid. While the gravitational pull of black holes is their most well-known feature, their role in creating intergalactic networks extends far beyond what is visible. These networks act as the power lines of the universe, transmitting not just energy but also information. The oscillations of black holes, the frequency of their emissions, and their gravitational ripples carry data about the state of the universe, much like a telegraph line carries messages. This cosmic grid ensures that changes in one part of the universe resonate throughout, maintaining a dynamic yet balanced system. Black holes in neighboring galaxies can influence each other through these networks, exchanging energy and aligning their motions in ways that reveal the universe's inherent synchronicity. This connectivity supports the idea that the cosmos is not a disjointed collection of phenomena, but a single, living system, where every part is interdependent. Through the harmonic mean, these intergalactic power lines form the backbone of this system, ensuring that the universe operates as a coherent and evolving entity. By Orion Carl Daly 7. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 12.12 The harmonic mean as the key to cosmic unity. The harmonic mean is the mathematical principle that makes these intergalactic networks possible. By balancing forces, distances, and energies, it creates a framework in which galaxies and black holes can interact harmoniously. This principle ensures that no single entity dominates the system, distributing energy and gravitational influence in a way that preserves the universe's equilibrium. It is through this principle that the universe's power lines remain stable, allowing galaxies to thrive as interconnected components of a greater whole. In this light, the universe can be seen as an intricate and self-sustaining network, with black holes serving as its power hubs. These intergalactic networks, governed by the harmonic mean, are not just a feature of the cosmos, they are its essence. They reveal a universe that is not only interconnected but also deeply resonant, where every connection, no matter how distant, contributes to the grand symphony of existence. 12.13 Intergalactic networks. The power lines of the universe. The universe is not a collection of isolated galaxies. It is an interconnected network, bound together by the unseen threads of energy and gravitational influence. Black holes, often viewed as singular and consuming entities, play a crucial role in this cosmic connectivity. Through the harmonic mean, they establish intergalactic networks that function much like power lines in a city grid, ensuring a seamless flow of energy and maintaining the equilibrium of the cosmos. Each black hole acts as a node in this vast network, its gravitational and radiative forces reaching across the void to connect with other black holes and galaxies. These connections are not random but are governed by the harmonic mean, a principle that balances energy exchanges across varying scales. The harmonic mean ensures that the energy flow between galaxies remains stable, synchronizing forces to create a coherent and self-regulating system. Much like an electrical grid balances supply and demand to keep a city powered, the harmonic mean balances the gravitational and energetic relationships across the universe, aligning disparate systems into a unified whole. 12.14 Cosmic networks and intergalactic resonance. Black holes are not isolated systems. They are interconnected nodes in an expansive intergalactic web. Through their resonant emissions, black holes communicate across galaxies, establishing energy pathways akin to power lines in an electrical grid. These connections create a self-regulating network where energy and matter flow harmoniously across the universe. Intergalactic connectivity. The harmonic mean governs the interaction between black holes and neighboring galaxies, creating a resonant network of energy exchange. This system ensures that the universe remains dynamically balanced, even as it expands. By Ryan Carl Daly 8. Cookbook for the Universe. Regulation of cosmic evolution. Black holes influence the evolution of galaxies by regulating matter intake and energy output. This regulation ensures that galaxies maintain their structures and continue their evolutionary trajectories in harmony with the larger cosmic framework. 12.15 Beyond the Horizon. A gateway to understanding. Relative gravity redefines the role of black holes, transforming them from enigmatic singularities to engines of resonance and regulation. Their mechanics, driven by principles of symmetry, harmonic resonance, and relative equilibrium, reveal the interconnected nature of the cosmos. By studying black holes through the lens of relative gravity, we unlock new perspectives on the universe's evolution. These cosmic engines, once feared and misunderstood, are now seen as the keystones of a balanced and resonant universe. Black holes demonstrate the property of synchronicity as described by C.G. Jung, having an inconstant connection through equivalence and a constant connection through effect. This synchronicity, as Carl Gustav Jung described it, demonstrates the interconnected nature of the universe. Black holes, while appearing solitary, are in fact nodes of a vast cosmic web, where their interactions maintain the stability and evolution of galaxies. Synchronicity, German. Synchronizität, is a concept introduced by analytical psychiatrist Carl Jung to describe events that coincide in time and appear meaningfully related, yet lack a discoverable causal connection. An inconstant connection through equivalence and a constant connection through effect. Cookbook for the Universe, from Einstein's Insight to New Frontiers. Understanding Mass Through Relative Gravity. Introduction to Einstein and His Formula. Albert Einstein revolutionized physics with his profound insights into the nature of the universe. Born in 1879, Einstein's work reshaped our understanding of space, time, and energy. His theory of relativity, which includes the iconic equation E=mc, brought to light the mass-energy equivalence. This equation reveals that mass m can be converted into energy E and vice versa, connected by the speed of light c. This insight showed that even small amounts of mass could unleash vast amounts of energy. Historically, this discovery has led to breakthroughs like nuclear power, revealing the profound connection between mass and energy. Einstein's equation E=mc was a monumental step forward, revealing mass-energy equivalence. Relative gravity reinterprets this formula by viewing mass not as static matter, but as energy in motion. We explore how mass m is expressed as m=ec, where energy E, including light itself, oscillates at the speed of light squared c. This means mass isn't a fixed entity, but a dynamic